All right, today we are going to be solving exponential and logarithmic equations. All right, so these are going to be equations that have like a 2 to the x in there or a log base 5 of x in there. So we're going to be trying to solve for x, and we'll need a new strategy for this. All right, so if you're going to solve an exponential equation, first thing we're going to do is isolate the term with the exponent. And you do the same thing when you're solving a quadratic equation. Like if we have x squared minus 5 equals 12, we would try to get that x squared by itself before we try to take a square root of both sides. So we're going to do that with the exponential part of the equation. And then just like with an x squared, you would take a square root because that's the inverse operation for x squared. We're going to make use of a logarithm for an exponential equation because logarithms and exponential functions are inverses. So we'll have to remember our triangle of power and our relationships between exponentials and logs. All right, so let's try to do one of these. So I've got this exponential equation here, and I've got our triangle of power and relationships down there on the right to remind us. So our first step is to try to get the exponential thing by itself. So we're going to think of this part here as a unit, and we're going to try to get the 5 and the 3 off of it before we start using the logarithm. Okay, so I am going to deal with the 3 first. So I'm going to add 3 to both sides. And that's going to leave me with 5 times 2 to the 3 minus x equals 15. And then we're going to get rid of the 5. The 5 is attached to the 2 by multiplication, so we're going to divide. And that leaves me with 2 to the 3 minus x equals 3. All right, so if you want to set up your triangle of power, we'll kind of do this up here. Well, let's do it down here. Okay, so I've got 2 to the 3 minus x equals 3. All right, so that's my DNA, and we're going to convert that to a log-or-dan statement. All right, so that's going to be the log base 2, the number that's on the left, of, let's see, the number that's on the right, equals the exponent. Okay, so that's my log-or-dan. And let's see, so by converting from the exponential form to the logarithmic form, now this x that I'm trying to solve for is outside of the exponent. It's down on the ground where I can deal with it. So let's focus on the x, forget about the fact that there's that log over on the left-hand side. And let's see, I want to get x by itself, so I'm going to subtract 3 from both sides. All right, and let's see what we have left. So on the left-hand side, I've got the log base 2 of 3 minus 3 equals negative x on the right. Okay, so the 3 that's in the logarithm cannot be simplified with the 3 that's outside the logarithm. Okay, so it's like the 3 is trapped inside the log function, and then the minus 3 is outside. So those are just going to stay the way they are. And the only thing I have left to do is to get the negative off of the x. So I'm going to divide both sides by -1. You could multiply both sides by -1. That would work just as well. And let's see, so that's going to cancel out that negative. And then I'll have x equals, and I'm just going to distribute that negative sign to both terms on the right. Okay, so I'm going to make the log base 2 of 3 negative. And the 3 on the right was already negative, so that's going to become plus 3. Okay, and that's our solution for x. And it's absolutely okay to leave that logarithm in there. If you would like to try to use a calculator to get a decimal, that's fine, but you can just leave it in exact form like this. Let's try another one. All right, so this one, our exponential term, is this e to the 2x minus 3. So we're going to try to isolate that before we start using a logarithm. So I'm going to subtract 2 from both sides, which leaves me with 7e to the 2x minus 3 equals, let's see, 10 minus 2 is 8. Now we want to divide by 7 to get the 7 off of the e, which leaves me with e to the 2x minus 3 equals 8/7. That's not a nice fraction. Just leave it like 8/7. It's fine. All right, so let's set up our triangle. So our exponential equation says e to the 2x minus 3 is equal to this fraction. And then we're going to use that to convert to a log statement. So we know we're going to have a log Our base is always the bottom left number, so that's the log base e. What's inside the logarithm is always the bottom right number. It's going to be 8/7. And then that's going to be equal to the exponent. The logarithm is always equal to the exponent. All right, so I've got the log base e of 8/7 equals 2x minus 3. I can leave that as it is if I want to. I can also remember that the log base e is the natural log. There's less symbols to write if I use that. So let's make this the natural log of 8/7 equals 2x minus 3. And then you're going to forget about the fact that we've got that ugly log on the left, and we're just going to focus in on the x. So just think about how you would solve any equation with a 2x minus 3. You'd start off by adding 3 to both sides. And again, we're just going to leave natural log 8/7 and then plus 3 on the outside. You can't combine the 8/7 and the 3, and that's equal to 2x. And then we're just going to divide by 2. And the thing over on the left is our answer. It's not a very pretty looking answer. And you could type that into your calculator. Natural log is really easy on a calculator of 8/7 plus 3 divided by 2, but I'm happy with you leaving that like this. We call that exact form because if you give me this answer, if I want decimal places, I can go to my calculator and get as many decimal places as I would like. We call it, if you type it into your calculator and give me the answer, we call that approximate, because you're going to naturally have to round that off at some decimals, and then you don't convey that information on your answer. All right. Okay, so that's it for solving exponential equations. And in the next video, I'm going to solve a couple of logarithmic equations.